So such type of product we are going to get over here. Hello everyone, welcome back to Plutus. So today we are going to discuss a various reaction of these haloalkane. So those who are new, they must know that we have already covered up the proper preparation of these haloalkane. So now we are going to discuss regarding some properties, and generally we discuss the chemical properties, or you can say the reactions which we are going to take place with the reaction of these alkyl halide, or you can say haloalkane. So generally these haloalkane, they show three type of reactions. One, they are going to show the substitution reaction. Another, they will be showing the elimination reaction. And the third reaction they are going to show is the reaction with metal. In today's class, we will be discussing specifically on these substitution reaction. So if you are not aware about like what is SN1, what is SN2, what is SNI, so all of them has been discussed in class 11. We have discussed regarding that nucleophilic substitution unimolecular, nucleophilic substitution bimolecular, what is the difference between them, which reagent is more probable for SN1, which substrate is possible, what are the possibilities for leaving group. That all has been discussed in quite detail in by the name SN1 reaction mechanism and SN2 SNI. This all has been discussed in class 11 GOC chapter. Today we will not go into the depth of this lecture. We will just go through the reactions which we are going to see over with this haloalkane. So nucleophilic substitution reaction. So the first reaction of this alkyl halide, so we are aware that this is Rx. So this is Rx. So as we know that this is the leaving group. So if this is the leaving group, because this is having partial positive charge and it is having a partial negative charge, which means this group has to be leave. And if we want to leave this group, so the necessary condition over here is going to be that some nucleophile is going to come over there and attack. So if we attack with the aqueous NaOH, if we are attacking with the aqueous NaOH, so what is the product? This aqueous is very important. If you are doing the reaction with alcoholic OH, the reaction results are going to be a bit different. So this is very important over here, that we need to take aqueous KOH, NaOH or KOH. So if we are having this Rx plus aqueous NaOH, so the reaction, the product of this reaction will be ROH. This part and this part like this. And this NaOH is going to leave out. So if we are having a reagent like this, CS3, CS2, CS3, CS2, Br, let's say, plus aqueous NaOH, or we can say aqueous KOH. So anything we can take over here. So all these like aqueous NaOH or aqueous KH. So what is going to happen? This OH negative partially, it will attack at this place, and this is going to leave out from here. So what is the product which we are going to get over here will be CS3, CS2OH plus KBr. So as we can see over here, so this reagent we are taking generally, these are our weak you can say nucleophile, because strong nucleophile due to this presence of Na. These are strong nucleophile. So we know that generally the strong nucleophile, they prefer the SN2 reaction, which means they are going to attack from the back side of this, which means generally these are SN2 reaction, and the product will be inversion product. Here we are going to see a inversion product. Okay, so now we will see a inversion product is going to be formed in such type of reagent, aqueous NaOH, aqueous KOH, and some two more reagent if we are taking a moist Ag2O and moist AgOH. Moist Ag2O or similar way CH3CH2 BrCl with moist AgOH. So this again we are going to get the product which we are going to get over here will be CH3CH2 CH3CH2OH. Here also CH3CH2OH. These are the product which we are going to get over here, and the remaining side product will be AgBr. Here also we will get plus AgBr. So these are also strong nucleophile. These strong nucleophile, so they will also prefer SN2 reaction. And the quiet detail we have discussed regarding these SN2 reaction, that here we are going to see the inversion in product, which means the inversion is going to take place over here, and the substrate which we are taking over here, they are preferentially 1 degree substrate. Generally SN2 reaction, they prefer the 1 degree substrate. If you need to know in detail why we are using only 1 degree substrate, then you have to go to the video of SN1 and SN2. So today I will just tell you that these are 1 degree substrate is preferred over here, and they are need a strong nucleophile. A strong nucleophile. They need some strong nucleophile to proceed this reaction. So in this reaction, when we are having a strong nucleophile, the reaction proceeds through the SN2 mechanism, and we are getting a inversion product. So these are the 4 reagents I have used over here. NaOH, either KOH, but the main thing over here is aqueous. It should be aqueous NaOH or aqueous KOH or moist Ag2O or moist AgOH. These 4 reagents, they prefer the SN2 reaction, and for SN2 reaction the substrate should be 1 degree to get a better product. So if we are having a reagent like this CH3CH2, if we are having a reaction like CH3 Br plus H2O in presence of only water, if we are taking this reaction, so this water, it is a weak nucleophile. This water is a weak nucleophile. We are aware that for weak nucleophile, we know the SN1 reaction is being preferred. We know that SN1 reaction is being preferred, and what is going to happen over here? And this reaction, SN1 reaction, prefer the 3 degree substrate, and we are having this substrate. So what will happen over here? This substrate will convert into this carbocation, and this water will attack over here from both the side. One will be the upside and another will be the below side. So we are going to get a 2 product. We are going to get over here one OH from this side plus carbon 1 OH from the back side. So both the retention and inversion. This is the retention product above retention plus inversion. So if our compound is chiral, then there is going to be much more detail to be explained. But here I have shown a simple achiral compound where all the C are same. So that's why there will be no more explanation needed. But we need to know that if the attack is from the back side, that we are going to get inversion product, and if attack from this side, so we are going to get the retention product. And generally nearly you can say 50-50% ratio they are being formed. This inversion is a bit in a more quantity as compared to the retention product. So this was for your, you can say, SN1 mechanism followed, carbocation is being followed. Or over here you need to remember that some heat is not given over here. So at higher temperature, what is may happen? This is a their elimination reaction can also proceed, that we will be discussing in the upcoming videos only. So just now to make you understand if we are having a weak nucleophile, there is a possibility that this reaction may proceed through the SN mechanism and we are getting a chiral compound, then the most probable is that we will be getting the racemic mixture. The most probability we are going to get a racemic mixture. So if we are going, this was a substitution by ROH. So fourth group we have discussed by KOH, NaOH, Ag2O and AgOH. These are like moist. This is aqueous KOH, aqueous NaOH, and these are like moist means water is present over here. Generally it is written as moist and it is also moist. So these reagents we have studied, but if we are having some other reagent such as RONA, some alkoxide type of reagent, if we are having some alkoxide type of reagent, if we are having, so what is the possibility over here? R1Br plus R2O negative Na positive. If we are having such type of reagent, then the possibility of this reaction is going through that this, in this we can see over here that this reagent will again attack from the backside because it is a strong nucleophile. This one is a strong nucleophile. The reaction will proceed through the SN1 mechanism. This reaction will proceed through the SN1 mechanism. It will attack from the backside. It will leave out a transition state is being formed over here, and we will get a product like this R1. This will leave out from here O and R2. So here we can visualize that the formation of ether is being formed, and this type of reaction is known as Williamson synthesis. Such type of reaction are termed as Williamson synthesis. If we are having an example, like CS3 CS2Br, if we are having an example like CS3 CS2Br with CS3 CS2 CS2ONA. So if this is the reagent, so we can visualize over here the product over here is going to be partial negative charge, partial positive charge. So it will attack at this place and this will leave down. So we are going to get CS3 CS2O CS2 CS2 and CS3. So in this we are going to get ethoxy propane. The compound which we are getting are ethoxypropane or ether are being formed over here. So now this is the way how we can synthesize, or you can substitute this Br or alkyl with this alkoxy part. We are substituting this with the alkoxy part. So now we will be seeing the substitution with the cyanide group. Substitution with the cyanide group, or you can say carbonitrile. Substitution with the cyanide or carbonitrile. If we are having a substitution with this cyanide group, so we are going to see here the two possibilities which we are going to visualize over here. When this is our RX, when it reacts with KCN, when this RX react with KCN, so what is the product which we are going to get over here? So we will be getting this KCN again negative charge. This is having a positive, it is having a partial positive charge. It will have a partial negative charge, partial positive charge and partial negative charge. So here the attack, and we are going to get a product like RC triple bond N plus Kx. So this is the product which we are going to get over here. So if we take an example over here, like CS3, CS2, CS2 Br plus KCN. So it will attack, this negative charge will attack, and we will get a product CS3, CS2, CS2, Cn. So here the one important thing we can visualize that we are increasing the chain. Here we are having 3-member chain, and in the product we are having a 4-member chain. So when we are reacting with KCN or NaCN, so such type of product we are going to get over here with the substitution of this cyanide. With the substitution of this cyanide, we are going to get such type of product. If we replace this Rx with AgCN, if we replace this Rx with the AgCN, so what we are going to visualize in this case now, so we will have some interesting results now we are going to see, and we will say RNC. We are going to visualize over here the product which will be formed over here will be RNC, and this, if you name this compound, this is like methane, ethane, propane, butane, butane nitrile. So this will be like our alkane isonitride. So if we are having an example like CS3, CS2, CS2 Br plus AgCN, it will give us CS3, CS2, CS2 and triple bond C. CS3, CS2, CS2 and C. So this is like propane isonitride. So the product over here is going to form is propane isonitride. So why we are having this difference in the product when we are having AgCN and KCN? So you can say that we are having Rx and we are reacting with KCN, we are getting RCN. But if we are reacting with AgCN, so we are getting R and C. So why is it so? Because if you visualize into the depth of this this AgCN, okay, in the next, this AgCN bond and KCN bond. So over here, if you see, this bond is covalent and this bond is ionic. So this bond is covalent and this bond is ionic over here. So one more thing which you will visualize over here, that this ionic bond, to break this bond is formed by the sharing of electron, and this is by ionic bond, just the presence of K is there, which means this, this C is having partial negative charge and it is having ionic form, which means they are ion. So this will be more reactive and it will attack as it will attack at RBr like this. But in this case, what is happening over here, this is a covalent bond. So here the lone pair, because here the covalent bond valency is filled up, so here this will attack at this position. So that's why we are going to get a product in which the nitrogen is linked with nitrogen due to the covalence character of this AgC bond, Ag and C bond. Here AgC bond is more covalent as compared to this KCN bond that is ionic in nature. So now again one more thing, now we will be seeing the addition of nitrite, or you can say substitution of nitrite. So in the case of this substitution of nitrite, what we are going to visualize over here that Rx plus KO and double bond O, or simply you can write down as KNO2. So what will happen over here? So there the bond, this is an ionic bond, and we are going to get a product RO and double bond O. This will be a product RO, R single bond O and double bond O, R single bond O and double bond O. This will be our product. Alkane nitride. So if we take some example like CH3, CH2, CH2, Br react with KNO2 or K single bond O and double bond O. So the product which we are going to get over here will be these three bond CH3, CH2, CH2, and after that this O and double bond O. Propane nitride. We are going to get propane nitride. But the similar case over here we have seen, we are going to get the linkage with this O. But if the same thing happen with Rx plus Ag O and double bond O. If the same thing happen with this, so now what will happen over here? Product which we are going to get will be like R and O2. Sorry. RNO2. So now we are going to get the nitroalkane. So why the product is being changing over here? If you visualize over here, CH3, CH2, CH2, Br plus AgO and double bond O. The product which we will get over here will be CH3, CH2, CH2 and double bond O, O negative. So what is that difference that we are getting NO2 with the place of AgNO2, but we were getting AgONO2 with KNO2. So the difference between this AgNO2 and KNO2 is similarly the same case as we have discussed earlier also. Now the same case happens over here, Rx with AgNO2 and KNO2. The products are going to be different. RNO2 with KNO2 we are getting RONO, nitro and nitride. So why this is happening over here? So if you visualize these bonds in quite detail, Ag and double bond O, sorry, and KO and double bond O. This is the bond formation over here. So here this bond is covalent. So this bond is not going to break. So this lone pair will attack at this R. But in this case, this bond is ionic. So this will going to attack over here. Due to the covalent nature, so we can say over here, due to the covalent and ionic nature difference in the AgONO2 and KONO2, nitro with the silver and with the potassium or you can say sodium, we are having different product. The main reason over here is that we are having a covalent bond when the Ag comes into the place. So now one more reaction which we are going to see over here, we will see the addition of HNS2. We are going to see the addition of KNS2 or you can say NS2 negative. This is our Rx when we react it with KNS2. This is our like KNS2 So what will happen over here? This is the base. So it will attack at this place, and this X is going to leave out from here, and we will get a product like R and S2. So as we know that this some more RX are also present over here, and this lone pair, it can attack on more, you can say RX, you can say this R is there, so this KNH2, so there will be some more attack will be there. We are going to visualize some more attack will be there with this R, and we will get a product like R and H R. So in this, if this again react with RX, so what it will happen? This base now attack at this side, this will leave down, so this will leave down, and we will have R and H over here, R and 2 H are there. This X will leave that H, this will take that H, and we again will have the base will have like this. So R and S2, again the similar case, we will having again the HX will react, and the similar type of product which we are going to get over here will be R and R, and finally we will have R. It will again attack, and the reaction will stop at this center. Some positive charge will be generated over here, and that negative charge, this positive charge moiety and the negative charge ion is going to be come over here to stabilize this reaction. So this is the formation of salt can take place over here, and this reaction is being termed as Hofmann reaction. So over here we have seen that this RX when reacted with KNS2 sodium amide, you can say, so this is the Hofmann reaction, Hofmann type of reaction which we are seeing over here. So if we quickly summarize the thing which we have discussed in the today's class, so we have discussed in quite detail regarding all the reactions of the haloalkane, the substitution, elimination, and the reaction with metal. So three type of reactions are there. So in the today's class we have discussed only the substitution reaction. In today's class we have discussed this part. This substitution part, it means the replacement of alkyl halide between this X with some upcoming reagent. So we can visualize over here that we have reacted with aqueous NaOH, aqueous KOH, or with moist Ag2O, or you can say moist Ag2OH. Then all those reagents, the reaction is proceeding through the SN2 mechanism, and we are getting an alcohol. And after this, if we react with the weak nucleophile such as water, so the reaction will proceed through SN1, and 3 degrees substrate is being preferred over here. So racemic mixture is being formed when we are having a chiral center or a chiral moiety. So this is like if we are reacting with this RNO2, RONA, like some alkoxide ion, so sodium alkoxide if we are reacting, so the synthesis of, you can say, ether is being formed in this type of substitution reaction. This is the reaction which I have shown you how we can prepare with an example also over here with the reaction with KCN. So with the KCN and AgSCN, we have discussed with the KCN the linkage was with the KCN the linkage was with the carbon, but with the AgSCN the linkage was through the nitrogen. In the same case happened with this nitrite also, that when we are taking the KCN, when we are taking the AgNO2, AgONO2, the linkage is through nitrogen, but when we are taking KONO2, the linkage is through the oxygen atom. So the same case over here, this is the Williamson amylysis, Hofmann amylysis, the reaction is Hofmann. I already told you there is a Hofmann amylysis because we are getting the ammonium salt over here. So this is the reaction when NH2 sodium amide is being reacted with this alkyl halide, and the several step takes place one and after again, and we are getting a salt is being produced in this. The final outcome of this reaction is the preparation of this salt. So this is the reaction which we have discussed in the today's class. In the next upcoming lecture, we will be discussing regarding the elimination reaction. elimination reaction and reaction with the metal. So be continued with this series. We are going to discuss each and everything in quite detail. And if you think that something is being missing over here, you can just comment that. I will upload the lead video for that also in quite detail. If you have any query regarding anything, that also you can comment in the comment box, and I will just revert back over there only. So that's all for today. Thank you.